Hello and welcome back. Today we will talk about algorithms in general and a specific type of algorithm in C. In C programming, an algorithm is a step-by-step procedure or method for solving a problem or accomplishing a specific task. Algorithms in C are typically implemented as sequences of well-defined instructions that detail how to perform a specific computation or operation. In programming, functions serve as modular blocks of code designed to perform specific tasks or computations. Algorithms, on the other hand, provide a detailed, step-by-step set of instructions that outline the logic and process behind solving a problem or achieving a particular objective. These are the common types of algorithms that we will cover: sorting algorithms, searching algorithms, and recursive algorithms. Sorting algorithms are used to rearrange elements in a specific order. They are essential for organizing data efficiently. For example, selection sort, bubble sort, and merge sort. Bubble sort works by repeatedly stepping through the list of elements, comparing adjacent items, and swapping them if they are in the wrong order. This process continues until no more swaps are needed. Selection sort divides the input list into a sorted and unsorted portion. It repeatedly selects the minimum element from the unsorted portion and places it at the beginning of the sorted portion. Merge sort follows the divide and conquer approach. It divides the input array into two halves, recursively sorts the halves, and then merges them back together in sorted order. Searching algorithms are used to find a target value within a collection of data. They help locate specific elements efficiently. Linear search works by sequentially checking each element in a list from the start until the target value is found or the end of the list is reached. Binary search is a more efficient searching algorithm for sorted lists. It repeatedly divides the sorted list in half and checks if the target value is in the middle. It then narrows down the search to the left or right half accordingly. Recursive algorithms are functions that call themselves either directly or indirectly to solve a problem by breaking it down into smaller instances of the same problem. For example, factorial function. Factorial calculation using recursion is a classic example where the factorial of a number is computed by recursively calling the factorial function for smaller numbers. Time complexity in algorithms. Time complexity in algorithms is a measure of the amount of time an algorithm takes to run based on the input size. It helps in understanding how the algorithm's performance scales as the input size grows. Space complexity refers to the amount of memory space an algorithm requires to complete a task in relation to the input size. Here are some keywords related algorithms. Big O notation represents the worst case scenario of an algorithm's time and space complexity. It provides an upper bound on the growth rate of the algorithm. For example, if an algorithm has a time complexity of O(n), it means that the algorithm's running time grows linearly with the input size n. Omega notation represents the best case scenario of an algorithm's time complexity. It provides a lower bound on the growth rate of the algorithm. For example, if an algorithm has a time complexity of omega n squared, it means that the algorithm's running time will be at least quadratic for large inputs. Upper bound, or O notation, as discussed earlier, denotes the worst case time complexity of an algorithm. It signifies the maximum time an algorithm may take to complete. For example, if an algorithm has a time complexity of log n, it means that the algorithm's running time grows logarithmically with the input size. Theta notation provides a tight bound on an algorithm's time complexity. It denotes both the upper and lower bounds, indicating the exact growth rate of the algorithm. For example, if an algorithm has a time complexity of theta n, it means that the algorithm's running time grows linearly with the input size and is both the best and worst case scenario. The most common types of complexities are the following. Constant time complexity, O1. Algorithms with constant time complexity have a consistent running time regardless of the input size. This means that the algorithm takes the same amount of time to complete regardless of the size of the input. Linear time complexity, ON. Algorithms with linear time complexity have a running time that grows linearly with the input size. As the size of the input increases, the running time of the algorithm increases proportionally. Quadratic time complexity, or ON squared. Algorithms with quadratic time complexity have a running time that grows quadratically with the input size. This means that the running time of the algorithm increases quadratically as the input size increases. Let's head to VS Code for practical example. I will open a file, code factorial.c. Now, I will implement a simple factorial function to demonstrate recursive algorithms. Hash include stdio.h, then hash include cs50.h, then end main, and inside parentheses void open braces close braces. Then inside my main function int num equals to get underscore int inside parentheses and quotations number colon and then a semicolon. Then return 0 semicolon. Now I will implement the factorial function. End factorial inside parentheses and then n. Then inside curly braces f n equals to 0 open braces close braces return 1 semicolon, else inside curly braces return n times factorial inside parentheses n minus 1, then a semicolon. Now beneath my header files, end factorial inside parentheses and n, then a semicolon. Now inside my main function, printf inside parentheses and quotations %d and exclamation mark equals to %d \n, then comma num comma factorial inside parentheses num, then a semicolon. Now I will explain this code. Int factorial inside parentheses int n semicolon declares a function prototype for the recursive factorial function to inform the compiler about the function's existence. Factorial num calls the recursive factorial function with the user provided number as an argument. Int factorial inside parentheses int n is our recursive function to calculate the factorial of a given number n. If n is 0, it returns 1. Otherwise, it recursively or repeatedly calls itself with n minus 1 and multiplies the result by n until n equals to 0. The recursive factorial algorithm works as follows. If the input n is 0, the function returns 1, which is called the base case. If n is greater than 0, the function recursively calls itself with n minus 1. The function multiplies the current value of n with the result of the recursive call for n minus 1. This process continues until the base case is reached. Once the base case is reached, the function starts returning and multiplying the results back up the call stack until the original call returns the final factorial value. Now to compile this, gcc factorial.c -o factorial -lcs50, then /factorial. It prompts you for a number. I will type 4. It outputs 24. So first, the function gets n as 4. Then it returns 4 times n minus 1 or 3. Then again the program takes the 3 and runs it in the function until n equals to 0. It then multiplies the results of each of this recursion and returns it. Thanks for watching. I hope you learned something new. Like and subscribe. Have a nice time.